In preparation for Desert Storm, the Allies had one very special aircraft capable of delivering laser-guided bombs, the F-111. Winning the war would have been much more difficult without it. Saddam Hussein's forces during the war in the Gulf were well entrenched. Often, targets were surrounded by civilians. Precise bombing was critical. Cruise missiles could do some of the job, but it was the ability of manned aircraft to repeatedly hit targets that was necessary to finish it. The F-111 was an aging veteran of the Cold War by the time of the Gulf action. It would be used exclusively to drop laser-guided bombs precisely on target. They would carry the Paveway 2 or 3. The F-111, or Aardvark, and its Raven electronic warfare variant, would be one of the most effective weapon systems in the Gulf campaign. The General Dynamics F-111 is one of the most controversial aircraft that ever flew. Perhaps no other aircraft before or since has been so bitterly criticized in the media. It suffered a protracted development cycle in which numerous serious problems had to be identified and corrected, and cost overruns became a serious concern. Of the several thousand that had originally been planned, only 562 flight-worthy examples of 7 different variants were completed. The F-111 was the subject of protracted and bitter debates within the Congress, with opponents denouncing the aircraft as a flying Edsel that was more dangerous to the U.S. than it was to any potential enemy. However, after a prolonged gestation period in which many problems had to be identified and fixed, the F-111 turned out to be one of the most effective all-weather interdiction aircraft in the world. Although vilified by some as being an unsafe and dangerous plane, the F-111 series of combat aircraft established the best safety record of any of the aircraft in the Century series of fighters. Only 77 aircraft being lost in 1 million flying hours. There is no other aircraft in service with the United States Air Force which can carry out the F-111's mission of precise airstrikes over such long ranges in all-weather conditions. It is still in service with the U.S. Air Force today and should remain in service until at least the year 2010. During Desert Storm, the 67 F-111Fs of the 48th Tactical Fighter Wing operated from air bases in Saudi Arabia. Because of their ability to deliver precision-guided ordnance in all-weather conditions, they played a key role in the destruction of the Iraqi command and control structure and in the elimination of key targets in the Kuwaiti theater of operations. These aircraft flew 2,500 sorties, destroyed over 2,000 targets, including direct hits on 920 tanks, 252 artillery pieces, 245 hardened aircraft shelters, 13 runways, 113 bunkers, and 12 bridges. A total of 5,500 bombs were dropped. Almost 85% of these bombs were precision-guided munitions. When Iraqi forces deliberately opened an oil pumping station manifold to allow oil to leak into the Persian Gulf, an F-111F was selected to deliver the GBU-15 electro-optically guided bomb against the manifolds to stop the flow. On the last night of the war, 2 F-111Fs delivered the hastily devised GBU-28 deep penetrator bombs against Iraqi command and control bunkers. These bombs could penetrate over 100 feet of earth or 22 feet of concrete. No F-111Fs were lost in combat during the Persian Gulf War, which is a remarkable testament to its combat effectiveness. The history of the F-111 begins back in the late 1950s. At that time, the Tactical Air Command, or TAC, expressed a future need for a replacement for the F-100, F-101, and F-105 fighter bombers, which were currently in service. At the same time, the Navy had a requirement for a 2-seat carrier-based fleet air defense, or FAD fighter, that would replace the McDonnell F-4 Phantom and the Vought F-8 Crusader. This aircraft was to have the ability to loiter on patrol for much longer times with substantially larger and more capable air-to-air missiles. The first test, F-111A, rolled out of the General Dynamics Fort Worth, Texas plant on October 15, 1964. A few months later, it took off on its maiden flight from Carswell Air Force Base. The variable geometry wing outer panels are pivoted to the fixed inner wing gloves and can be driven symmetrically to any sweep angle from 16 to 72.5 degrees. The upper surface of the wing has a set of spoilers, which are used for roll control, no ailerons being provided. The main wing has a set of double-slotted flaps, which occupy the entire trailing edge of the wing. The flaps are disconnected when the wing is at maximum sweep, so that they cannot be operated in such a configuration. Two Pratt & Whitney TF30P3 afterburning turbofans power the ship with 18,500 pounds of thrust, allowing a better than 25,500 feet a minute climb rate to its combat ceiling of 58,000 feet. If it has to, it can add another 10,000 feet of altitude beyond that. The ship has a better than Mach 2 speed limit with a combat radius of 1,300 miles. Its ferry range with external drop tanks is over 3,000 miles. And of course, with aerial refueling, its range is limitless. It's set up for a flying boom probe coming off a KC-135 tanker. This was a frequent method of refueling during Operations Desert Shield and Storm. It allowed all the coalition planes to run continuous CAPs, or combat air patrols, on a 24-hour basis over the Kuwait-Iraq theater of operations. It has a real nasty sting in its nose with a 20mm M61A-1 rotary cannon with 2,000 explosive-tipped rounds. The ship is well able to take care of itself when it goes in alone. It also has some formidable missile hardware to take out an enemy fighter. In standard form, the F-111A's useful payload varies from 8,000 pounds to 20,000 pounds, according to range. For example, for a mission range of 1,725 miles, the payload is of the order of 16,000 pounds. In an extreme situation, the F-111A could carry as much as 50 750-pound conventional bombs, 2 of them being carried internally and the rest on 6 underwing hardpoints, or 26 1,000-pound bombs. However, such loads could only be carried if the wing is swept no more than 26 degrees. But at lesser angles, the ship's underside fairly bristles with either drop tanks or rockets and bombs, depending on the need. These are drop tanks, shed when empty. And of course, no one wants to be on the ground underneath these babies. Here the ship fires off its tank-busting rockets, a type of ordnance very useful in the Gulf War. If the pilot detects a ground-based radar has locked onto him, he can release flares or chaff to confuse a radar-locked incoming missile. The landing gear level brings the tricycle wheels into position for the touchdown. The rear wheels have an extendable apron that not only protects the wheels, but acts as an air brake, slowing the ship quickly, either for landing or in combat, which would cause an adversary to overshoot his quarry. The F-111 receives constant maintenance to make sure the varying wing sweep option is always available to the pilot and weapons officer. The farther back they're laid, the faster the ship can fly. A set of slats occupy the entire width of the wing leading edge, and a set of heavy-duty flaps on the trailing edge. These sets can be extended by a rack and pinion system when the aircraft is flying at low speeds or at high angles of attack to increase lift and to prevent the aircraft from stalling. With the wings laid back, the F-111 resembles nothing so much as a lethal, high-tech arrowhead for an archer's hunting bow. In effect, that's what it is and does. It causes extreme grief when it strikes its quarry. With the wings far forward, the ship can fly at much slower speeds and looks kind of like a flying penguin to those below. The F-111 for a time directly challenged the Soviets when the Aardvark was considered a static nuclear bomber. When the B-1 bomber project was canceled, it was the F-111 that would have been the one alternative to the B-52. The F-111 reverted to conventional missions once the B-1B and the B-2 programs were underway. Still, they gave the Soviets reason to worry as a new unit of the 340th SAC Bombardment Group. The F-111, while not a small ship by any means as far as fighter bombers go, is quite a step down from a B-1 or a B-52 or even a B-2 stealth in terms of size. But it's far faster than any of those, able to come in fast, do its business, and then get out fast. This particular ship is a Raven, the ECM variant of the F-111. Recognizable by the canoe-shaped pod atop the tail. In the late 1960s and early 1970s, the Air Force was shopping around for possible replacements for its Douglas EB-66 electronic warfare aircraft. Although the EB-66 still continued to fly combat missions over North Vietnam, it was rapidly beginning to show signs of age. The Air Force rejected the development of a completely new type of aircraft for this role as being economically impractical because of the small number of aircraft required. After some thought, the Air Force concluded in 1972 that the modification of some existing F-111A strike fighters would be the most cost-effective solution. The Soviets had some ideas of their own regarding variable sweep aircraft and came up with this copy of the Aardvark. They called it the MiG-23. These days, the Russian radar early warning system is in shambles, with only 3 of 9 satellites in orbit functioning. This has resulted in a 6-hour hole on one side of the 24-hour clock and a 1-hour gap on the other in terms of satellite surveillance. But their ground stations are functioning normally within Russia itself. Most of their early warning systems are now, since the Soviet Union's breakup, based in other countries far from Russia's own borders. But this is the ship the F-111 had most to fear from in the skies over Vietnam, the MiG-15. MiG-17s were there as well. There was no way the Aardvark was going to turn with these fighters, but then it didn't really have to. The Aardvark was supersonic in a very real sense, while the MiG-15 was not, and the 17 just approaching that goal. Manufacturing the different variants of the F-111 was a highly complex process. Thousands of miles of electronic cabling and wires go into the machine, especially the Raven, the ECM variant, and attention to detail was paramount, especially given all the early complaints about the ship. But those were more of a question of initial design than flaws in the manufacturing process. That pod looks awfully small, but without it, the Raven would be just so much junk on the runway. With it, it can go ahead of a main strike force and totally disrupt all the sophisticated electronic defenses of the enemy. It doesn't have to fly slow to do this either. With its wings folded back and flying high at supersonic speed, it goes in over the targeted area like a bullet. And thanks to that better than Mach 2 speed limit and onboard ECM avionics, it's almost impossible to hit. Maintenance crews sometimes display a proprietary interest in their individual ships, which they merely lend to the pilot and weapons officer. The two men are admonished to bring the ship back unharmed, preferably without a scratch. Most of the time, they do. Fueling is taking place for a training mission. Cushion screens, normally placed over the air ducts to keep birds and moisture out, are removed in readiness for imminent flight. The crew receives its briefing, during which the exact parameters of the mission are laid out. The Raven's avionics package is very sophisticated, and modifications included the installation of an AN/ALQ-99E jamming subsystem. The pilot and the ECM officer take their places and strap in. Instrumentation is checked out on the console, and the necessary synchronizations are verified for the avionics aboard. Before every flight, the hydraulics supporting the variable wing configurations are also tested. Takeoffs are almost always with wings fully extended to increase lift. Elevators are also tested. One by one, all the aircraft's controls are checked out prior to takeoff. If anything's wrong, now's the time to find it out. The pilot wants no surprises aloft. The big ship begins to taxi to its runway in preparation for takeoff. Wings and flaps are at full extension. Exciters, antennae, and other items pertaining to the ECM package are mounted on a pallet inside the internal weapons bay. The fin-tip pod accommodates the electronic countermeasures receivers. The SE-1F protection subsystem consists of a jamming system and a countermeasures dispensing set. The terminal threat warning subsystem was also installed, which consists of infrared and electronic countermeasures receivers. The vertical tail fin had to be reinforced in order to support the fin-tip pod. New electrical wiring had to be installed. 60 kVA generators were replaced by 90 kVA units, and since all that stuff can heat up pretty fast, an improved environmental system for electronic equipment cooling was also added to the package. F-111A Ravens were deployed in support of Operation Desert Storm in 1991. They flew over 900 sorties. None were lost in combat, but one was lost in a non-combat related accident and both crew members were killed. The F-111A Raven was even credited with a kill during Desert Storm. On the night of January 17, 1991, an Iraqi Mirage F-1 flew into the ground while chasing an F-111A. Although the Raven is unarmed and has no air-to-air capability, the Raven crew was given credit for the kill. The pilot and ECM man sit side by side in the cockpit, which has a clear field of view in nearly all directions except directly aft. The systems are now turned on. It's time for the Raven to do its thing, to jam enemy radar systems on the ground that might otherwise track and guide missiles to destroy airplanes on a strike mission. Normally, the strike force would be just a minute or two behind the Raven. The flashing light on the ship's underbelly is matched by one in the cockpit to tell the pilot and his partner that everything is working normally. The pilot wants to get a little more altitude on this mission. And here's why. Mountainous terrain is not the best to fly over in terms of forced landings. Not that they necessarily would have to, but more altitude offers more time to correct any flight problems that might surface, like the unlikely possibility of the plane being disabled by a missile strike. This is a very real possibility in mountainous terrain like the Balkans, where the Raven and other Air Force planes have flown and will continue to fly for some time to come. Despite the Raven's ECM duty, which it performs very well, mountains can also be an advantage for an incoming strike fleet. By staying low, radar signatures are masked by the surrounding peaks. In just such terrain as this, the Bosnian Serbs are known to have SAM sites scattered all over, with dozens of radar positions supporting not only the SAM batteries, but anti-aircraft guns as well. Coming out of the mountains means dropping down closer to the deck. The F-111 was used in limited missions at the end of the Vietnam War, but it would be its service in the Mediterranean which would bring the aircraft to popular attention. 24 F-111Fs from the 48th Tactical Fighter Wing, based at Lakenheath in the UK, spearheaded the U.S. punitive attack on Libya on the night of April 14, 1986, striking targets in Tripoli with laser-guided and retarded bombs. One of the planes was lost to ground fire during the attack. It received a lot of press coverage in the U.S. media, primarily because of alleged civilian collateral damage during the strike. The United States Air Force today seems of two minds about the F-111. One faction appreciates the plane's multi-role capabilities and wants to keep it on. Yet another complains of its age and points out that newer model aircraft are shortly to come online, which will be tasked with handling all the jobs the F-111 has been doing extremely well for over 25 years. It's hard to imagine another aircraft which will be an enormous leap forward in technology. Any improvements over the F-111's capabilities will no doubt be of a marginal nature. Hardly anything aloft flies faster, even today, and nothing performs quite like the EF-111 Raven in its strike escort role. Neither is it likely to be superseded by another fighter bomber which can carry more than the enormous tonnage the F-111 can already carry aloft and deliver in the ground attack role. In the end, it will no doubt be a budgeting decision by the Air Force in deciding the fate of this airplane, which is still ranked among the superfighters of today. Its only perceived weakness was an inability to turn with much more maneuverable but slower fighters of an earlier time, which would never catch it anyway. Critics complain of this disadvantage even more loudly today, when the newest superfighters are not only as maneuverable, but just as fast as the old Aardvark. Nevertheless, this is an airplane that, like an aged prize fighter who hasn't lost his legs or his punch, refuses to go down.